Okay. Uh, yes. So good evening, dear students. Right. So Saturday, we have completed Amin's chapter. Right. So today, new chapter we are going to start today is biomolecules. Yes. What are biomolecules and what do you understand by this word biomolecules? Can anybody tell me? Yes. What do you understand by the word biomolecules? What are biomolecules? Yes. So biomolecules are nothing but these are the complex organic substances, right? These are the complex organic substances which build up the living organism. So our human body, right? Human body, it is made up of what? It is made up of this different complex organic substances. And these complex organic substances, these are required for the body, right? It is required for the human body for their growth and maintenance. Okay, for the growth and metabolism, for the growth and their maintenance, we require these complex organic substances. Can you name some of the complex organic substances which is required by our body? Can you tell which are the different complex organic substances which are required by the body? That is a human body, okay, living organism. Any living organism, maybe the animals, maybe the human beings. Yes, anybody try? Which are the different complex organic substances? So if you want, you can unmute yourself or you can drop the message in the chat box. Yes, glucose, proteins, right. So what are these glucose? Glucose, okay, proteins are okay, fine. What are these glucose? They come under a complex substance, that word, what it is called as? It is called as carbohydrates, right? So yes, very good. So biomolecules, what are these? These are the complex organic substances which are used by the living organisms, right, for their growth and maintenance. So different biomolecules are your carbohydrates, proteins, nucleic acid, okay, then lipids, hormones. So these are essential for the human body, right? These are essential for the human body. Fine. Okay. So so the branch of chemistry which deals with these complex organic substances, we are going to understand the function and okay. So these all so these things we are studying under one specific branch of chemistry, and that is called as biochemistry. Okay, that particular branch is called as what? Biochemistry. So what we are studying in biochemistry, we are studying about these organic compounds only. Okay, about these complex organic substances. Okay, we are going to study the structure, we are going to study the functions, okay, how it is going to interact with our human bodies. Okay, so these all things we are going to study, and this study, it is done in a particular different section, and that is called as, okay, let us start with our first let us start with our first what is that compound. Okay, first, okay, so we have just discussed about, okay, what all we have discussed. Let us see. So we have discussed what are biomolecules, okay, then we have discussed what is biochemistry, right? So then, so what are these organic compounds? Yes, complex we said, complex organic compound. Organic compound means nothing but they are made up of carbons. Okay. So carbon, it is present in most of the living matter. Okay. So most of the or living matter consists of carbon, right? So these biomolecules, either they are inorganic or they are organic. So just now we have discussed organic biomolecules. So which are the different biomolecules? That is carbohydrates, lipids, amino acids, proteins, enzymes, nucleotides, nucleic acid, vitamins. Okay. And which are the okay. So the so these are the different organic biomolecules, and inorganic means okay, inorganic with minerals, gases, water. Okay, so these are the inorganic biomolecules. Fine. Next, biomolecules, they are of two types, micromolecules and macromolecules. What do you mean by micromolecules? Micro means small size. Okay, we cannot see it by our naked eye. We cannot see from our eyes. So they are so small size. Okay, and macro means they are large size. So the carbohydrates, lipid, proteins, so this can be seen by our the eyes. Okay, they are large size. So the carbohydrate, lipid, protein, nucleic acid, and the minerals, gases, water, sugars, amino acid, nucleotides. So these are all micromolecules. So micro and macro. So remember the difference. Micro means very small and macro means large. Okay, large size. Okay, so what are the different functions? So these we are going to discuss one by one. Okay, so before going for the DNA, so today first we are going to start with the first complex organic compound. Okay, that is our carbohydrates. So first we are going to start with carbohydrates. Okay, our first complex organic substance. So what are these carbohydrates? So carbohydrates, these are the hydrates of carbon. Okay, what they are called as? They are called as the hydrates of carbon. Okay, so these are most abundant organic molecule found in nature. So this is one of the most abundant. Abundant means what? It is found in large quantity. It is present in more quantity. Okay, so these are the most abundant organic molecules which is found in the nature. Okay, so hydrates. What do you mean by hydrates, students? Hydrates means water molecules is associated. So carbohydrates means what? So these are considered as the hydrates of carbon. Okay, and the general formula is CnH2ON. Okay, it consists of water. Hydrates of carbon means your oxygen and hydrogen. It is in the form of combined. Okay, it is in combined form of water. It is how it is in the combined form of water. So hydrates of carbon. What they are called as? They are called as hydrates of carbon. That is CnH2O. Okay. So remember what are carbohydrates? Carbohydrates are hydrates of carbon. What they are? They are the hydrates of carbon. Okay. So here, what is the ratio of hydrogen and oxygen? It is in the ratio of 2 is to 1. Okay, it is in the ratio of 2 is to 1. You know, water. Water, how it is water? Water is H2O, right? So hydrogen is in 2 ratio and water, oxygen is in 1 ratio. Right, so it is present in hydrates of carbon, which is in the ratio of Yes. So we were discussing what? We were discussing about the, yes. So what we were discussing, students, we were discussing about the ratio, right? So hydrates of carbon. So what is carbohydrates? Carbohydrates are nothing but they are the hydrates of carbon. Okay. They are called as what? Hydrates of carbon. So then which are the examples of different carbohydrates? So we have discussed about glucose, right? Glucose, what is the formula? C6H12O6. Okay, then we have discussed about fructose. Fructose, what is the formula? This is also C6H12O6. Okay, then we have discussed about the next carbohydrate, that is sucrose, which is C12H22O11. So these are the different carbohydrates. Okay, so these are the different carbohydrates. So here, so these are the different carbohydrates. So these carbohydrates, they are generally called as the optically active. Remember this word? They are called as optically active. Okay, they are called as optically active polyhydroxy. Okay, polyhydroxy. They are called as what? Optically active polyhydroxy aldehyde or ketones. Okay, so these are available in the form of aldehydes or they are in the form of ketones. Okay, so here what we are saying about carbohydrates, they are called as optically active polyhydroxy aldehydes or they are the ketones. Okay, so these are your carbohydrates. So let us see the classification of carbohydrates. Okay, let us see the classification of carbohydrates. So based on the number of units present in the carbohydrates, okay, they are categorized into three types. So they are categorized into how many types? They are categorized into three types. Okay, so what are the different three types? So first one is the monosaccharide. Okay, first one is what? Monosaccharide. Second one is the oligosaccharide. Second one is what? Oligosaccharide. And third one is polysaccharide. Third one is what? Polysaccharide. So based on what? Based on the number, how many number of units are produced. Okay, number of units are produced. They are characterized as no, oligo, and polysaccharide. Okay, now what are this monosaccharide? What do you mean by the word monosaccharide? Okay, so these are the simplest carbohydrates. So these are the simplest carbohydrates. Okay, these cannot be hydrolyzed further. So these will not give you simple units upon hydrolysis. So when you are hydrolyzing this monosaccharide, you will not get any smaller units. Okay, so these cannot further hydrolyze. So monosaccharides, they are what? They are the basic units. You can say they are the basic units, okay, which cannot give you further hydrolyzed units. They cannot give you hydrolyzed units. So which are the different monosaccharides? Okay, you need to know this example, students. Please remember. So glucose. So glucose is the monosaccharide. Okay, then fructose is the monosaccharide. Then you have ribose. Okay, ribose is also a monosaccharide. Then you have galactose. Okay, then you have what? Galactose. So these are some of the simplest monosaccharide units. Okay, so these are the simplest monosaccharides units. So which are the simplest monosaccharide units? Glucose, fructose, ribose, galactose, etc. Okay, so these, what you know that after hydrolysis, they will not give you or they will not yield you simple units. Okay, so this you have to remember. So about 20 known monosaccharides are there. Okay, there are around 20 monosaccharide. So the general formula of monosaccharide is CnH2nOn. Okay, it is CnH2nOn. So this is the simplest monosaccharide unit. Okay, then so this depends on what? Okay, so this is the about monosaccharide. Further, we are going to discuss about oligosaccharide. Mono means one. Okay, you remember that mono means one. Now, what do you mean by oligosaccharide, student? Oligo means few. Okay, oligo means oligo. The word oligo means few. So these are the carbohydrates. When you are hydrolysing, will give you 2 to 10 monosaccharide units. So when it undergoes hydrolysis, okay, when it undergoes hydrolysis, will give you what? It will give you 2 to 10 monosaccharide units. Remember that? So whenever your oligosaccharide, so these are the carbohydrates. When it is undergoing hydrolysis, they will give you how many monosaccharide unit? Yeah, they will give you 2 to 10 monosaccharide units. Okay, so which are the different monosaccharide oligosaccharides? Okay, so sucrose, okay, sucrose will come, then maltose will come, okay, maltose, then is your lactose. Okay, then here is your lactose, then is your raffinose. Okay, remember, please remember the examples, very important. Okay, so these are the oligosaccharides. So these are the carbohydrates. When it will undergo hydrolysis, will give you around 2 to 10 monosaccharide units. Okay, so these are the different example. So these oligosaccharides, so they are further divided as disaccharide, trisaccharides, and tetrasaccharides. Disaccharide means what? When it will undergo hydrolysis, you will get two uh, two simple units. Okay, you will get two simple units upon hydrolysis. Trisaccharides means what? When they will undergo hydrolysis, when the carbohydrates undergo hydrolysis, you will get three simple units. Tetra means four. Okay, so oligosaccharide based upon how many number of monosaccharide units are undergoing hydrolysis. So they are further classified as di, tri, tetra saccharides. Okay. When they undergo hydrolysis, depending upon the number of units, okay, they are classified as disaccharides, trisaccharides, and tetrasaccharides. So this is our second classification. Third one is polysaccharides. Poly means many. Poly, the word poly means what? Many. So these carbohydrates upon hydrolysis will give you many numbers of monosaccharide unit, or they will give you large number of monosaccharide units. Now, which are the examples? The examples is starch, cellulose, okay, glycogen. Okay, so these are some of the examples of polysaccharides. So these carbohydrates, when they will undergo hydrolysis, they will give you large number of monosaccharide units. Many number of monosaccharide units are you will get, okay, when it undergoes hydrolysis. So these are the classification of carbohydrate depending upon the number of units which are produced upon hydrolysis. Okay, mono means one, oligosaccharide, and polysaccharide. So these are the three classification. Is it clear up to your classification? So we have discussed about the classification of carbohydrates based upon the number of simple units. Okay, when it will undergo hydrolysis. Is it clear up to this part? Yes. So we have discussed about the classification of carbohydrates. So we have understood about monosaccharides, polysaccharides, and oligosaccharides and polysaccharides. Yes. Is it clear?
Yes, ma'am.
Okay. Fine. So let us study further. So further, so second classification is, okay, so carbohydrates can also be classified as reducing sugars. Okay, further they are classified as reducing sugars. So this is the first classification. And secondly, they can be classified as non-reducing sugar. Okay, so this is the second classification. So first was based upon the number of simple units. So this is second classification. So for carbohydrates can further be classified as reducing sugars, and they are classified as non-reducing sugars. Now, what are these reducing sugars? Okay, so carbohydrates which reduces Fehling solution. Remember this definition? Okay, asked frequently for exams or competitive. What are reducing sugars, and give example. So the carbohydrates which reduces Fehling solution, okay, and tolerance reagent are called as reducing sugar. What they are called as? They are called as reducing sugar. So what are reducing sugars? So the sugars, okay, the carbohydrates which reduces Fehling solution and tolerance reagent. Okay. Now, what are this Fehling solution and tolerance reagent? They are some of the reagents. Okay, they are the reagents which are used to detect the carbonyl group. Okay, so the carbohydrates which will undergo, okay, when it reduces this Fehling solution and tolerance reagent, they are called as reducing sugars. So which are the examples of reducing sugar? Maltose, okay, maltose and lactose. So these are the so all the monosaccharides are reducing, and only few disaccharides are reducing sugars. Okay. Now, what is non-reducing sugar, students? Non-reducing sugars. What are non-reducing sugars? So the carbohydrates which do not reduce, okay, which do not reduce Fehling solution, okay, which do not reduce Fehling solution and tolerance reagent. Okay, they are called as what? Non-reducing sugars. Okay, they are called as non-reducing sugars. So which reduces are called as reducing sugar, which do not reduces Fehling solution and tolerance reagent. They are called as non-reducing sugars. So please mark this very important definitions. 2 marks definition. What are reducing sugars? Give example. What are non-reducing sugars? Give example. So what is the example for non-reducing sugar? Sucrose. Okay, sucrose, then trihalose. Okay, and trihalose. So these are the examples of non-reducing sugar. So what are non-reducing sugars? So sugars which do not reduce Fehling solution and tolerance reagent. Is it clear? Is it clear about what are reducing and non-reducing? Okay, fine. So this was a important part. So I just took that. Okay. So next classification is based upon the number of carbon atoms. Okay. Now, based upon the number of carbon atoms, they are called as depending upon the number of carbon atoms. If there are 3 number of carbon atoms, then they are called as triosis. If there are 4 number of carbon atoms present, then they are tetrosis. If 5, pentosis. If 6, hexosis, and 7, heptosis. So depending upon how many number of carbon atoms are present in the carbohydrates, they are classified as triosis, tetrosis, pentosis, hexosis, and heptosis. So please see the example. What are the examples of triosis? Glyceraldehyde and dihydroxyacetone. Tetrosis, erythrose, and threose. So these are the examples, okay, where you can see the number of carbon atoms are 4. Okay, how many number of carbon atoms are present? 4. Pentosis, the number of carbon atoms are 5. So which are the examples? Ribulose, xylose, arabinose. Okay. So these are the examples, or deoxyribose. Okay. So these are the examples of the carbohydrates which consist of 5 carbon atoms. The next one is hexosis. Next is what? Hexosis. Okay. So hexosis, which are the examples? Glucose, fructose, galactose, and mannose. Okay. So these are the carbohydrates which consist of 6 number of carbon atoms. 6 carbon atoms are present. Glucose, fructose, galactose, mannose. So they are termed as hexosis. Then heptosis means what? They consist of 7 number of carbon atoms. So which are the examples which comes under heptosis? Pseudoheptulose and glucoheptose. Okay. So these are the classification based on the number of carbon atoms. So monosaccharides are further divided like this. So second classification is based on the functional group. Okay, based on the functional group. Monosaccharide means what? So these are the carbohydrates which will not undergo further hydrolysis, or they consist of only one simple unit of sugar. Okay. Now, these monosaccharides, they are further classified based on the functional group. If there is a aldehyde present, if there is a aldehyde group present, what is aldehyde? We have studied now what is aldehyde. C double bond O H, right? So if there is a aldehyde group present in the compound, then they are termed as aldoses. What they are termed as? They are termed as aldoses. So which is the examples of aldoses? Glyceraldehyde, glucose. Okay. So in this carbohydrates, okay, in the structures of this particular carbohydrates, you can see there is a presence of a aldehyde. So they are termed as aldoses. Okay, they are termed as what? Aldoses. So if there is a ketone present, if there is a ketone, okay, R, C double bond O, R dash. So if there is a ketone present, the functional group ketone, if it is present, then they are termed as ketosis. What they are called as ketosis. So depending upon the functional group, they are termed as aldoses or ketosis. So ketosis, what is the example? Fructose. So if you write the structure of fructose, so here you can see this is the structure of fructose, okay, which is given here. You can see there is a presence of a ketone, okay, and here you can see there is a presence of a aldehyde. Okay, here you can see there is H at one side. Okay, here you can see both are R dash only. Okay, both are R dash. So because of this, this is a ketone, this is a aldehyde. So based upon the number of functional group, they are termed as what? Aldoses and ketosis. Okay, understood? Okay, so what all we have seen? We have seen what are biomolecules. Okay, then we have studied what is biochemistry. Then we have discussed about the first biomolecule, that is carbohydrates. What are carbohydrates? Right. Then we have discussed the classification of our carbohydrates based upon the number of simple units as monosaccharides, oligosaccharides, and polysaccharides. Then we have discussed what are reducing sugars, what are non-reducing sugars. Then we have discussed about this what are, so based upon the number of carbon atoms, how these monosaccharides are classified. Then we have discussed about based on the functional group, how they are classified, aldoses, ketosis, and their examples. Okay. Is it clear up to here? Yes. Any doubts? If you have any doubts, you can ask me. Yes. Any doubts up to here? Okay, fine. So let us continue. Then we are going to study about the preparation of glucose. Okay, we are going to study the preparation of glucose. So what is glucose? So glucose is called as the cane sugar, grape sugar. Okay, it is called as grape sugar. So glucose is called as what? It is called as the grape sugar. Okay, it is a dextrose present in what? It is present in sweet fruits. So where is this glucose present? Glucose is present in fruits, that is sweets, fruits, and in honey. Okay, in honey. So what it is called as? It is called as grape sugar. So how we are going to prepare this glucose? Okay, we are going to see the preparation of glucose. So first preparation is that we can prepare our glucose from cane sugar. What is cane sugar? Sucrose. Okay, we can prepare our glucose from cane sugar. That is our sucrose. So how is this preparation? So when we take sucrose, okay, sucrose when it undergoes acid hydrolysis, okay, when our sucrose undergoes acid hydrolysis, it undergoes what? It undergoes acid hydrolysis. What it will give you? It will give you glucose and fructose. It will give you what? Glucose and fructose. Remember that? Remember that? Okay. So whenever, how we can prepare glucose, the first preparation. Okay, what is the first preparation? We can prepare our glucose from sucrose. So when we take sucrose or when we take the cane sugar, and if it undergoes acid hydrolysis, hydrolysis means what? It will undergo hydrolysis in the presence of water. Okay, it will undergo hydrolysis. In the hydrolysis means in the it will react with water in the presence of a acid. Okay, which acid we can take? We can take HCl. Okay, we can take H2SO4, which will generate protons. Okay, so we are going to react our glucose with water in the presence of acid. Okay, and what we are going to get? And this will be a alcoholic solution. It will be a alcoholic solution, and it will give you glucose and fructose. Okay, it will give you glucose and fructose. So like this we can prepare our glucose. Okay, like this we can prepare our glucose. So this is the first preparation. So this is our first preparation. Then second preparation is what? Okay, second, we can prepare it from starch. Okay, we can prepare our glucose from starch. Okay, how we can prepare from starch? Okay, this is at commercial. Commercial means what? When we want to prepare glucose at a large scale, we want in more amount. When we want glucose in more amount, that time we can prepare the glucose from starch. So at a commercial scale means at industrial scale, at a very large scale, when we want it in more amount. So glucose can be obtained by using starch. What is starch? C6H10O5. Okay. So this is starch. So starch, when it undergoes acid hydrolysis, okay, it will undergo acid hydrolysis at 393 Kelvin. So the temperature, that is at 393 Kelvin and 2.3 atmospheric pressure, you are going to get what? Glucose. You are going to get glucose. Okay. So this is the second method of preparation. So this is the second method of preparation. Okay. So what is the difference between glucose and fructose? Okay. Glucose and fructose, what did I say? It is C6H12O6. C6H12O6. Both are disaccharides. Okay. Sorry, this is a monosaccharide and this is also a monosaccharide. How we obtain this? We obtain this when we do acid hydrolysis of sucrose. Okay, so sucrose is a disaccharide. So when it undergoes hydrolysis, okay, when it undergoes sucrose, when it undergoes hydrolysis, it will give you two monosaccharide units of one of glucose, one monosaccharide unit of fructose. Okay, now here, what is glucose? Glucose, if you see the structure of glucose, it consists of a aldehyde group. Okay, it consists of a aldehydic group. And in fructose, you have a ketone group. Okay, the only difference, both are monosaccharide unit itself. Both are carbohydrates. Okay, both are having same formula, C6H12O6. But what is the only difference? This comes under aldosis. Okay, your glucose comes under aldosis. Your fructose comes under ketosis. Understood? Understood now? Okay. So your glucose comes under aldosis and your fructose comes under ketosis. It consists of a keto group. So the molecular formula is same. Only the difference is this. Okay, fine. So this is the only difference. Fine. So let us go further. So when we want to prepare glucose at a very large scale means what? At a commercial scale. Okay. So that time we are going to do acid hydrolysis of what? Of starch. So we are going to take starch or we can take cellulose. We can take starch or cellulose. We are going to do acid hydrolysis. Okay. We are going to take acid. We can take HCl or H2SO4. Okay, at a temperature of 393 Kelvin and under a pressure of 2.3 atmospheric pressure, we are going to get what? We are going to get glucose. Is it clear? Okay, so these are the two methods. Remember that these are the two methods. One, we can prepare from sucrose. Okay, and second is from starch. Fine. Okay. Next, we are going to see the structure of glucose. Okay. Next, we are going to see the structure elucidation. We are going to describe the structure of glucose. Okay, we are going to describe the structure of glucose. Structure elucidation of glucose. Okay, we are going to see the structure elucidation of glucose. Fine. So let us start with the structure elucidation. So the elemental analysis, when we carry out, so scientists, when they have carried out the elemental analysis, okay, so the molecular mass, when the structure elucidation, okay, when the structure elucidation what was carried out when we were determining the structure of the glucose after undergoing the molecular mass and the elemental analysis. Okay, after understanding which all elements are present in glucose, after studying this, okay, so the molecular formula. So the molecular formula of glucose was found to be C6H12O6. So after studying, after understanding the molecular mass and after determining the molecular mass, okay, after determining the molecular mass and after studying the elements, what are present in the structure of glucose, we came to know that the molecular formula of glucose is C6H12O6. Remember that? Okay, remember that. So this was the first point. Second one was what? So it confirmed that, how to confirm that there are 6 carbon present. Okay, so second was to study the presence of 6 carbon atoms. So how the presence of 6 carbon atoms was confirmed and how these 6 carbon atoms are present in a straight line, okay, or straight chain. So what was done? So CHO, so this was the short, okay, this was the formula of glucose. So this was the formula CHO, CHOH 4 times, okay, and CH2OH. So this was the structure of glucose. So when we take the structure of glucose, okay, when we take glucose and if we heat with hydrogen iodide, if we heat the glucose with hydrogen iodide, okay, what we get? We get N-hexane. We get what? We get N-hexane. So this confirmed that. What it confirmed? It confirmed that, okay, there are 6 carbon atoms which are linked in a straight chain. So when glucose was heated with hydrogen iodide, it gave, okay, it gave you what? It gave uh, N-hexane. Okay, it gave N-hexane. Okay, so this indicates that there are 6 carbon atoms, and these 6 carbon atoms, they are linked in a straight chain. Okay, so these are linked in what? These are linked in the straight chain. So if they ask you, okay, to confirm the presence of 6 carbon atoms in a straight chain, you have to give this test. Okay, you have to give this test. So you have to write the structure of glucose, then you have to heat it with HI in the, okay, you have to heat it with HI, and what you're going to show? N-hexane. Hexane means what? 1, 2, 3, 4, 5, 6. The number of carbon atoms are 6. So this confirms the structure of glucose consists of 6 carbon atoms which are linked in a straight chain. Okay, is it clear up to here? Is it clear up to here, students? So two things we have discussed. First was how we came to determine the molecular formula after undergoing the after determining the molecular mass and after undergoing the elemental analysis, that is which all elements are present, we came to know the molecular mass. Then to confirm that the 6 carbon atoms are present in the glucose atoms, and that too in a straight chain, then this was the particular test. Okay. Then third was the presence of carbonyl group. The presence of what? The presence of carbonyl group. So how was this presence of carbonyl group detected? Okay. So again, glucose was taken. Okay. So CH, OH 4 times, and CHO and CH2OH. So glucose, when it was treated with hydrogen cyanide, okay, when glucose was treated with what? Hydrogen cyanide, it gave you what? Cyanohydrine. It gave you what? Cyanohydrine. So the rest all things were remaining intact. Okay, CHOH 4 times and CH2OH. At this carbonyl carbon, what happens? One will be CN, another was OH. Okay, so what was formed? Glucose cyanohydrine was formed. Okay, glucose cyanohydrine was formed. So this was when you reacted with hydrogen cyanide. Another test was when it was reacted with hydroxyl, that is hydroxylamine. Okay, when it was reacted with hydroxylamine, it gave you glucoxime. Okay, it gave glucoxime. So this confirmed that, so only at the carbonyl carbon there was the presence of, rest all was same. Okay, the rest all structure was same. So this confirmed that there was a presence of carbonyl group. So glucose, it reacted with hydroxylamine. Okay, so this was hydroxylamine. So glucose, it reacted with hydroxylamine to form oxime. Okay. And also when we added hydrogen cyanide, okay, when we added hydrogen cyanide, okay, cyanohydrine was formed. What was formed? Cyanohydrine was formed. What it indicated? Yes, students, what it indicated? It indicated that there was a carbonyl group present. What do you mean by carbonyl group? C double bond O group was present. Okay. So this confirmed that there was a carbonyl group. Is it clear? Is it clear, the third test? Okay. So in the structure, there was a carbonyl group. The first test, what we have seen that what was present in the first test. We have first we have determined the molecular formula. Second, we have seen to the presence of 6 carbon atoms, and these 6 carbon atoms, they are linked in a straight chain. Okay, they are linked in a straight chain, right? Then what we have seen third test, how to detect the carbonyl group. Carbonyl group means what? We have a aldehydic group in that, right? Carbonyl groups can be anything. One can be a aldehydic group and ketone. So we have said that in glucose there is a aldehydic group. Okay. So at this carbonyl group itself, rest all structure is same. Rest all structure is same. Only at this carbonyl carbon part, you can see there is a formation of oxime and cyanohydrine. So what this shows you that there is a what is there? There is a presence of carbonyl group. Okay. Next test, presence of, so which is that carbonyl group? So this is a aldehydic group. Okay, so second test, next test was that this carbonyl group is nothing but it is a aldehydic group. So what was done? Again, glucose was taken. Okay, again, glucose was taken, and this glucose, it was treated with bromine water. Okay, it was treated with bromine water. After treating with bromine water, our aldehyde group, it gave acid. It gave what? It gave acid. What is bromine water? Bromine water is a oxidizing agent. What is bromine water? Bromine water is a mild oxidizing agent. Okay, it is a mild oxidizing agent. Okay, it is a mild oxidizing agent. So what it did? It converted our aldehyde group to COOH group. That is our aldehyde group was converted into a carboxylic group. Okay. So this confirmed that the carbonyl group present in the your glucose is a aldehydic group. Okay. It is a aldehydic group. Is it clear? Yes. Is it clear up to here? So we have seen 4 tests. Okay. We have seen 4 tests. Fine. Okay. Yes. Next one, we are seeing the next, we are determining the structure, right? So next one was, there is a presence of 5-OH group. Next was the presence of 5-OH group. Okay, so what was done? So again, our glucose was taken. Okay, glucose was taken. And this glucose was treated with acetic anhydride. Okay, it was treated with acetic anhydride. So what is the structure of acetic anhydride, student? CH3, C double bond O, O, CH3, C double bond O, O. So this is acetic anhydride. So what was done? Glucose was taken, and this glucose, what was done? It was treated with acetic anhydride. Then what was done? You can see this OH groups are there, right? So this here 4 OH group and here 1 OH group is there. So wherever the OH groups were present, there acetyl group was added. Okay, OCH3 group was added. OCH3 group was added. So this was the structure. So CH2O, C double bond O, CH3. So this what was formed? So glucose pentaacetate was formed. Okay, glucose pentaacetate was formed. What was formed? Glucose pentaacetate was formed. Fine. So this confirmed that there are 5 OH group. So you can see in the structure here, CHO, CHOH 4 times and CH2OH. So there are 4 OH here and there is 1 OH. So to detect the presence of 5 OH groups in the structure of glucose, what we did? We reacted it with what? We reacted it with acetic anhydride. Okay, we reacted it with acetic anhydride. So when it reacted with acetic anhydride, what happened? All the OH group were converted into acetate groups. Okay, they were converted into what? They were converted into acetate group. And we got glucose pentaacetate. So acetylation was done. What we did? We did acetylation. Sorry, acylation. Okay, what we did here? We did acylation. So acylation of glucose, we did acylation of glucose, okay, with acetic anhydride, with acetic anhydride. And what it gave? It gave you glucose pentacetate. Okay, it gave you glucose pentacetate. And what it confirmed? It confirmed that there are 5 OH groups. Okay, this confirmed that there are 5 OH groups. Is it clear? Okay. Is it clear? So 5 tests we have seen. Okay. 5 tests we have seen. One more test. Okay. So one more test and then we will. So next was presence of primary alcoholic OH group. Okay. Primary alcoholic OH group. So how this was given? So again, glucose was taken. Glucose was taken. Okay. It was, we had to done. So glucose was taken and we did oxidation. Okay, glucose when it was on oxidation with nitric acid. Okay, so when we did oxidation with nitric acid, nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. So when we did oxidation with our nitric acid, okay, what was done? It was both the aldehyde group and the primary OH group was converted into acid. Okay, it was converted into dicarboxylic group. Okay, it was converted into dicarboxylic acid. It was converted into dicarboxylic acid and it is called as what? It is called as saccharic acid. Okay, it is called as saccharic acid. Okay, as well as if you take gluconic acid. So this is our gluconic acid. So if you take gluconic acid, okay, if you take gluconic acid and if you do oxidation with the help of nitric acid, you are also going to get what? You are going to get the dicarboxylic acid. So what is done? Both the aldehyde group and the alcoholic group is converted into acidic group. So when we are doing oxidation with nitric acid, glucose, okay, the glucose, your glucose as well as your gluconic acid, what is done? It is converted into saccharic acid. It is converted into what? Saccharic acid. So this indicates that the OH group present is what? The OH group present is a primary alcoholic OH group. The OH group present is primary alcoholic OH group. Fine. So when we are doing oxidation with both, when we are doing oxidation on glucose with nitric acid, what we are going to get? We are going to get the saccharic acid as well as when we are doing oxidation of nitric acid, okay, with nitric acid on that is your gluconic acid, that time also we are going to get the saccharic acid. So this confirms that the OH group what is present, it is what? It is a primary OH group. Primary means what? Okay, the OH group is directly attached to only one sp3 hybridized carbon, then it is called as primary OH group. Okay. So based on this above this reaction, so we have seen 6 reactions. So based on all the reactions, so the structure was given and the structure of the your what is that? Glucose was given like this. So this is a complete elucidation of glucose. Okay, this is a complete elucidation of glucose. So this is a complete structure of glucose. So please write down this. I hope all the reactions you have written. So what all we have studied. So first test was the molecular formula C6H12O6. Second, it confirms the presence of 6 carbon atoms. So which are the 6 carbon atoms? 1, 2, 3, 4, 5, and 6. So 6 carbon atoms. Okay. Third test was what? There is a presence of a carbonyl group. Okay. Presence of carbonyl group. Okay. So second one was 6 carbon atoms in a straight line. In straight line. Then third one was carbonyl group. Fourth test was what? That the carbonyl group is a aldehyde group. Okay, the carbonyl group is a aldehyde group. So that test also we have seen. So there is a aldehyde group. Then fifth was what? Fifth was there is a presence of 5 OH group. Presence of 5 OH group. How it was done? By doing the acetylation. So which are the 5 OH group? 1, 2, 3, 4, and 5 OH group. Right. So there are 5 OH group also. So how we have confirmed? By treating it with acetic anhydride, we got glucose pentaacetate. Then sixth one was that what we did in sixth one, that there is a presence of primary alcoholic OH group. Alcoholic primary primary alcoholic group. Okay, primary alcoholic group. So which is the primary alcoholic group? This one. Okay, this one is the primary alcoholic group, OH. So this OH group is a primary alcoholic. Is it clear up to here? So this was the structure of glucose. So all the reactions are clear. So reactions are asked. Okay, how the question will be asked? How will you confirm the presence of 6 carbon atoms? So you have to give the what reaction? Glucose. You have to react it with HI in the presence of heat. What you are going to get? You are going to get N-hexane. So that particular reaction you have to show. So if they ask you, show the presence of carbonyl group. So how you are going to show the presence of carbonyl group? Yes, you are going to react it with either hydrogen cyanide, it will give you cyanohydrine, or when you react the glucose with hydroxylamine, it will give you a oxime. So like that reactions, all the reactions you have to show. Is it clear? So this is about the glucose. Okay. So in today's class, we have discussed about what is biomolecules, what is biochemistry. Then we have discussed about the carbohydrates classification, different classification, and we have discussed about glucose completely. Okay. The structure of glucose we have discussed. So some more things are there. Okay. So that let us see that all things in the next class. Is it fine? Okay, any doubts up to here? Anything you want to ask? You can. Anything you have to ask, you can ask. So the remaining part, okay, so it is easy. Okay, it is very easy. So please go through the things, whatever have been told. So remaining things I'll be discussing in the next class. Okay. So fine. So if there are no doubts, so I shall stop the class here. Okay, we'll meet in the next class. Thank you.